nonlinear partial differential equations in P and Q. So we learned how to solve linear partial differential equations. Now nonlinear partial differential equations is classified into type 1, 2, 3 and 4. So type 1, equations containing P and Q only. That is, the form is, it takes a standard form, f of pq equal to 0. That is, it contains only, if any equation contains only P and Q, then we can classify it in type 1 and solve according to type 1. According to type 1, solution for f of pq equal to 0 is z equal to ax plus by plus c. So we should put in the given equation, we should put p equal to a and q is equal to b, and find, and we'll get f of ab equal to 0, find b in terms of a and substitute in z equal to ax plus by plus c. So solve p square q cube equal to 1. Okay, so that we can see that by inspection the equation has only P and Q, so it falls in type 1 non-linear partial differential equation. It is very clear that the equation is non-linear because linear equation is in the form of PP plus QQ equal to R. Hence we see that P square Q cube equal to 1 is a non-linear PDE. So, and it falls in type 1. Therefore, put P equal to A, Q equal to B. We get A square B cube equal to 1. So, B cube is equal to 1 by A square. Thus, B is equal to 1 by A square power 1 by 3. That is cube root of 1 by A square. Now, solution for an equation of this form is AX plus BY plus C. So, in place of B, we have found B as a function of A. Hence, z is equal to ax plus 1 by a square power 1 by 3y plus c. Now, next problem, q is equal to e power minus p by alpha. So, we see that this equation has only p and q terms, okay, rather than p, q, z, x, y. Okay, a function should be a function of x, y, z, p and q. But if it contains only p and q, then it falls in type 1. So this equation is of type 1 nonlinear PDE. Hence put p equal to a, q equal to b. Then b is equal to e power minus a by alpha. Solution, z is equal to ax plus by plus c is the solution, standard solution for this type 1. So in place of b, we should write function of a. Here b is found to be e power minus a by alpha. Thus z is equal to ax plus e power minus a by alpha y plus c. Okay. Now third problem, p square plus q square equal to npq. So equation is containing only p and q. So put p equal to a, q equal to b. Thus a square plus b square equal to NAB, b square, okay, so writing it in standard form, b square minus NAB plus a square equal to 0. So we should always find b in terms of a. Okay, so this is similar to a quadratic equation, ax square plus bx plus c equal to 0. Thus b is equal to minus b plus or minus root b square minus 4ac by 2a, right? So we are using that formula. Thus b is equal to na plus or minus root n square a square minus 4a square by 2. Now here a square is common, okay, so it becomes a root n square minus 4. So take a common, we'll get a by 2 n plus or minus root n square minus 4 by 2. Therefore, z is equal to ax plus a into n plus or minus root n square minus 4 by 2 into y plus c. Next, solve x square p square plus y square q square equal to z square. So, equation 1 is not in f of pq equal to 0 form. Hence, we should reduce it to f of pq equal to 0 form. Therefore, we are grouping it, dividing throughout by z square, and we'll get xp by z whole square plus yq by z whole square equal to 1. By using some substitutions like u equal to log x, v equal to log y, w equal to log z, we get p equal to dou z by dou x. But dou z by dou x can be written as dou z by dou u into dou u by dou x. Further, p is equal to dou z by dou x, that is equal to dou z by dou u into dou u by dou x, that is equal to, okay, so dou u by dou x is 1 by x. So 1 by x dou z by dou u. Okay, so left hand side is p, right hand side is 1 by x dou z by dou u. So we can write this cross multiplying, we can write it as xp is equal to dou z by dou u. Similarly, xq is equal to dou z by dou v. But w is equal to log z. We can write it as dou w by dou u equal to dou w by dou z into dou z by dou u. So dou w by dou z is equal to 1 by z into dou z by dou u. That's equal to xp by z. Okay. So dou z by dou u is found to be xp. So we'll get xp by z. Similarly, dou w by dou v is equal to yq by z. Now, substituting this in equation 1, in this equation, we'll get dou w by dou u whole square plus dou w by dou v whole square is equal to 1. So, let dou w by dou u equal to p, capital P, dou w by dou v equal to q. Then the equation becomes an equation of type 1 form, because it would be p square plus q square equal to 1. So according to type 1, z is equal to ax plus by plus c. But here the variables that we have used is w with respect to u and v. Hence w is equal to au plus bv plus c. Okay. So put p equal to a, q equal to b in this equation. Then a square plus b square equal to 1. b is equal to root minus a square plus 1, that is root 1 minus a square. So w equal to au plus bv plus c gives us w equal to au plus root 1 minus a square b plus c. But initially the problem has x, y and z terms. Therefore, solution should also be in terms of x, y, z. Therefore, substitute for u, v and w. Thus, log z equal to a log x plus root 1 minus a square log y plus c. So, this is type 1 partial differential equations in nonlinear.